Lesson 22, Comparing Dot Plots. Alright, so here's our first question, and it's asking us, what is the mean of the following dot plot? Well, in order to figure out the mean, we need to add up all of our numbers and then divide them by how many we're adding to figure out our average. Remember that whenever you're asked what is the mean, it's also asking what is the average. So looking at this data here, I have 3 ones, which means if I were to write out my data, I'd have 1, 1, 1, 4 twos. So I'd have 2, 2, 2, 2, 3 threes, 4 fours, I'd have 5 fives, and 3 sixes. So this would be that data set written out from this dot plot. So every dot above your number is how many of that number you have. So remember, to figure out your mean, what we need to do is add all of these together and then divide it by the total. So I'm just going to quickly add up what all of these dots represent. So what I did here was I knew that there were 3 dots above 1, so that's 3. 4 dots above 2, 4 times 2 is 8. 3 dots above 3, 3 times 3 is 9. 4 dots above 4, 4 times 4 is 14. 5 dots above 5, 5 times 5 is 25. And 3 dots above 6, so 6 times 3 gave me 18. So that gave me a total of 79. So I need to divide that by how many dots I have. So I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Divide that by 22 and I get 3.59. And I'm going to round that to 3.6. So the mean or average of this data set would be 3.6. The next question is using the same data, but we want to know what is the range. So the range is how far apart these numbers differ. Kind of like, where's the starting, where's the ending, and what's the difference between those two. So to determine your range, you need to take your largest value and subtract it from your smallest value. So largest value here is going to be 6, and smallest value here is going to be 1. So 6 minus 1 gives me 5, and that is my range. Next question is asking, what is the mean absolute deviation, or MAD, of the following dot plot? So this is where, in order to figure this out, remember, first we need our average, or our mean. Our mean for this data set we already found out was 5.6, I believe. Oops, 3.6. And to determine our mean absolute deviation, we need to take this mean and subtract it from each one of our data points to determine how far apart they are. So if I do 3.6 minus 1, 3.6 minus 2, 3.6 minus 3, actually I'm going to flip this because I want my bigger number to go first, because I always want to have positive numbers. And then I'm going to bring back our calculator and we're going to subtract all of these. So 3.6 minus 1. Alright, so here are all those numbers. And I'm going to move this over here and then copy them onto our PowerPoint. So this is 2.6, 1.6, 0.6. This would give me 0.4, 1.4, and 2.4. Alright, now this is where you have to remember with these dot plots. I have 3 values that are at 1, which means that when I'm adding this 2.6, which is what is the distance between our mean and this point value 1, I need to add 2.6 3 times. Okay, so again, I'm adding this 2.6 3 times, because when I look at my dot plot, I have 3 dots above 1, which means I would have 3 2.6 values. Then when I move on to number 2, I have 4 dots above 2, so I'm going to add this 1.6 4 times. And then with this 0.6, I have 3 dots above 3, so I'm going to add 0.6 3 times. And then with 4, I'm adding 0.4 4 times. With 5, I'm adding 1.45 times. 1, 2, 3, 4, one more. And then with 6, I'm adding 2.43 times. Alright, so when I add all of those together, I get 31.8. Now again, to figure out our mean absolute deviation is taking the average of the distances of all of these points here. So I'm going to divide this by how many numbers we added, which would be the same as the first time. So I'm just going to double check and recount to make sure I'm putting in the same number. So this is 3, 7, 10, 14, 15, 16, 17, 18, 19, 20, 21, 22. So when I divide that by 22, I get 1.4, which means that my mean absolute deviation for this problem is 1.4. So this would be my MAD, my mean absolute deviation, 1.4. Alright, next question says that we have this dot plot here and it represents samples for the number of household members in 2 different neighborhoods. Based on examining the dot plots visually, which neighborhood seems to have the larger mean in household size and why? So remember, mean is your average. So if I look at this very first example we did, most of our dots are kind of focused in the center. They're somewhere around here. This is where most of our data is. So when I find the average, I would expect my data, or my mean, to be somewhere in between these two, because that's where our data has the most points, which is true. I got 3.6. So if I look here, most of my data is going to be between this 4 and 5. And if this is that same dot plot we did, most of our data is going to be between 3 and 4. So that means that neighborhood B is going to have a larger mean because the points are more clustered in the middle. Notice how they're more clustered in the middle here versus here they're much more clustered to the left. And on the left of our number line, we have smaller numbers like 1 and 2. And we are looking for a larger mean, so we want a bigger number. Next question says we have these 2 different companies and they represent the results of customer service surveys ratings from 1 to 10. Based on examining the dot plots visually, which company is most likely to have a greater mean score and why? Well, Company A has many more people that have taken the survey, and majority of their answers are a 4 to 5, which means that their mean is probably going to be around a 4 to 5. And if I look at Company B, less people have taken it, but more of the results are between 7, 8, and 9. So since 7, 8, and 9 have the most dots above them, that means this is probably where my mean is going to be, around here. And 7, 8, and 9 is larger than 4 and 5. So Company B is going to have a greater mean score because the points are more clustered on the right. And on the right side of our number line, which is over here, that is where all those bigger numbers are. Alright, so variability. The main thing to remember with variability is this. The bigger your mean absolute deviation, so the bigger your MAD, the more variation you are going to have. The smaller your MAD, the less variation you are going to have. Okay, so they correlate with each other. The bigger your mean absolute deviation, the larger your variability. The smaller your mean absolute deviation, the smaller your variability. So with this question here, it tells us that the mean absolute deviation for neighborhood 1 is 1.4, and the mean absolute deviation for neighborhood B is 1.6. So neighborhood B has a larger variation because it has a larger mean absolute deviation. We want to know which one of these statements best compares the variability. This first one says neighborhood A has more variability in the household because it has a lower MAD. Well, that's not true because it's not bigger, so it doesn't have more. B says that neighborhood A has more variability in the household because it has a greater, but it doesn't. Neighborhood B has a greater variation because the mean absolute deviation is larger. So D says neighborhood B has more variability in the household size because it has a greater mean absolute deviation. This is the key part here. Whichever has the largest mean absolute deviation is going to have the greatest variability. And our last question says that we have this table here and it shows the mean and mean absolute deviation for the cost of 4 shirts at different stores. We want to know which store is most likely to have the least variability. Well, if it has the least variability, I am looking for the smallest mean absolute deviation, which means I don't care about the mean. All I am looking for is mean absolute deviation. And since I'm looking for the least, I'm looking for which one has the smallest. And down here, store 5 has a mean absolute deviation of 0.5, which means that store D, sorry. So store D would have the least variability because it has the smallest mean absolute deviation. Okay, anytime you have a question and it uses the word variability, you need to pay attention to the mean absolute deviation, nothing else. So mean absolute deviation will tell you everything that you need to know about your variability. And that is all that I have. So please let me know if you have any other questions or would like some extra work with this. Other than that, have a wonderful rest of your day.